exponential growth and decay. You just graph them. Okay? Now we're going to talk about how they affect the real world. Where will you see these in the real world? So, growth. If something grows exponentially, it grows really fast. Okay, it's not steady like a line. Linear is slow and steady growth. Exponentially means it climbs faster and faster and faster. That's why it kind of shoots up the way it does when we've been graphing it. So, examples in the real world. When you hear a rumor, you know, there used to be a commercial back in the 70s for like hair shampoo or something. And it was like, and then I told two friends, and then so on, and they told two friends, and so on, and so on. And what would happen is, like, the girl's picture would split to two, and then two and two, and then the whole screen was everybody saying, and so on, and so on. And what it was growing faster and faster. Okay? So, you know, so if you tell someone a rumor, and they go and tell two people, and each of those people tell two or three people, and each of those people tell two or three people, boom! It explodes. Or on social media, what happens? We say it goes viral. So when something goes viral, it's growing exponentially. Okay, it's growing faster and faster each day. When you have an outbreak, like the plague, back in the old days, back in the ancient times, during the 1400s, whatever, the bubonic plague or the black plague, these things spread faster and faster. Bacteria usually grows at an exponential rate. Hopefully, if you're investing money, compound interest, it grows faster and faster because you get interest on the money you earn. And then when you earn more money, you earn interest on that money, and it grows exponentially. Okay? So, let's see what these things mean in the formula. Y is the future amount. Abbreviate amount. So Y is the future amount. So how much money will there be? Okay, so how many bacteria will there be in 5 hours? How many people will have heard the rumor in 2 days? C is the initial amount, our starting amount. Okay, so how many bacteria were there to start? How many sick people were there to start? How much money did I put in the bank? R is the rate. Here's the important part. As a decimal. Okay, you've got to change it to a decimal. So, for example, 11%, you got to move the decimal 2 places to the left, equals 0.11. 2.5% equals 0.025, and so forth and so on. Okay, so you must move the decimal 2 places to the left. And then T, no surprise there, stands for time. And your graph is going to look like we've been graphing exponential growth. As time increases, this is shooting up faster and faster, depending on the data. Okay? So, we'll see some examples here. Local university tuition has been increasing at a rate of 5%. Now, right away, I would suggest as soon as you see that percent, change it right there. Every year since 2000. If the tuition was 2000 was $10,850, give the equation that gives the tuition after T years, just whatever T is. Okay? Well, we don't know that amount. Okay, it's going to be some future amount. Our initial amount goes outside the parentheses. And then it's 1 plus, what's our percentage of decimal? 0.05. And t goes up there. So if I said 2 years, in 2 years, boom. If I said 10 years, put the 10 in there. Or if I gave you a year, like how much was it in 2015? Well, then you have to subtract 2000 from 2015 to find out it's 15 years. So for example, based on that, the year 2020. The year 2020 minus 2000 is 20 years. So t equals 20. So that's what we're going to put in for t. So we put 10,850, 1 plus 0.05 to the 20. So we take our calculator and we type in 1.05 to the power of 20, then times 10,850. Yes, 1 plus 0.05 is just 1.05.
I got 28788.
So, if you entered it correctly, and you should all be doing this to make sure you did it right, you should have 28,788, and then it's 0.28. 28 cents. Yes, 28 cents. And you keep it 28 because the third number is a 0. And 0 to 4 means stay the same. So if you didn't get that, do it again. Type in 1.05 caret 20, enter, times 10,850. And you should get 28,788.28. Caret 20, because that's this number right here.
Oh,
Okay. And we're not going to worry about sketching it. Just generally on the graph, it's going to be good looking like that. Okay? We're not going to sketch it on a graph. It's just going to have that general shape. Okay. Decay. Well, decay is, if you ever buy a car, a brand new car, and you drive it off the lot, immediately it depreciates. It loses value the moment you hit the street. And it goes down all the time. Unless it's an antique car. Then it would appreciate and it would be growth. But generally, cars decrease in value.
What if you drive around a lot?
It decreases in value.
wait, does it decrease by like 30,000?
It depends on the car.
If you push it.
Like you take, say you got like.
Well, if I bought a $20,000 car, it's not going to depreciate by $30,000.
I'm talking like 30,000.
I'm never going to buy a car that depreciates by $30,000. I'm going to buy a car that costs $30,000. So, loss of profit. If you got a business, that's losing money, this happens. It might be losing it exponentially. Okay.
Okay.
Radioactive decay. Okay, you ever see in the movies when they have those called Geiger counters? They're going, and they're trying to pick up radiation. Okay, radiation decays over time. Or when they look at what's called carbon dating, and they find a fossil, they do carbon dating to find out how old it is, how many hundreds of thousands of years it is. Or we talked about a disease. If you treat it, hopefully the cure has an exponential rate of decay. So these are not really going to change. This is the end amount or the future amount. This is still the starting amount. This is still the rate as a decimal. And this is the time. But notice, decay goes this direction. Over time, it's going down, decreasing.
So
time increases this direction, our amount goes down. So over time, remember we talked about the first quadrant is real world, time moves left to right. As time goes on, our numbers decrease quickly.
Hope so.
Not by yourself.
All right. A truck made in 2007 was sold initially for $10,500. Each year, it decreases at 10% rate. So let's write the basic equation. Why? We don't know the future value. We don't know how many years we're talking about. But the initial amount always goes right here, 10,500. Now, since it's decay, we're going to do a minus sign. And then our rate right here is 0.10, or just 0.1. And we put a t up here. Now, how much would it be worth this year? Well, this is 2019. We subtract 2007 and you get 12 years. So t is 12. You always got to find t. Now, 10,500, 1 minus 0.1 raised to the 12. Now, you got to be careful of this. When we're doing addition, we can just write 1 point whatever. But subtraction, you got to do that first. So, right now, everybody type in 1 minus 0.1. No, not 1 minus 1.1. 1 minus 0.1. You should have just gotten 0.9. Okay.
Yeah.
Now raise that to the 12th power. And you should get something like 0.282429536.
You're correct.
Now do that times 10,500.
I got 296.51.
So $2,965 and then 51 cents. So you got a car for 10 grand, 10 and a half, 10,500, and 12 years worth just about 3 grand. If it goes down 10% per year. Again, we're not going to sketch this specifically. We're just going to say generally it looks like that. That's a decay graph. Now, the next one, I'm not telling you what it is. You need to read the problem and figure out, is it growth or decay? So you got to look for a clue word. It says in 2008, the population was $280,000. With a growth rate. Now, it may not say growth rate. It might say appreciation, increased, went up. These all mean plus. Now, some of you, very common mistake here, say, oh, it's already a decimal. No, it's a decimal percent, which means you still got to move that decimal 2 places to the left. Okay? Just because it's already a decimal means nothing. You got to change it from a decimal percent to just a straight decimal. And we go from percent to decimal by moving 2 places to the left. So, y equals 280,000 parentheses 1 plus, since it says growth, 0.0085, and we put a t. So 2018 minus 2008, t equals, no, not 2010, it's just straight 10.
Yeah,
How do you get 10?
So y equals 280,000, 1 plus 0.0085, be careful about the number of zeros, and then 10. 2018 minus 2008. It doesn't say this year, it says 2018.
Does it look like I'm going to fall asleep?
So, type in 1.0085 raised to the power of 10 times 280,000. You should end up with 304,731. Now, since we're talking about people, we round to the nearest person. Can you have 0.29 of a person? So, about 304,731. And again, just a general idea of the sketch of the graph.
I'm talking about the work. Because you just started me. I'm trying to ask a question.
All right. Due to particular treatment, infected cells are declining. Declining means decay, so we'll use the -1. 2.5%, move it twice, 0.025. And yes, it says per hour. So y equals did it give us an amount?
No.
So we just put the letter A there. 1 minus 0.025 to the t. So if we don't know, we just put A for the letter. That's our starting amount. Right, so we just put A to represent some number. That's the general formula. Now, it's telling us here, we start with 2,500 people that are sick. 1 minus 0.025, and it says 1 full day. Now, listen carefully. Listen carefully. This is where the mistakes happen. It says 1 full day. Do we put a 1 up there?
No.
You gotta look at what this says. It says per hour. The formula is based on hours, so then you have to calculate 24 hours in a day. So take your calculator. It says right here, started with. What I did was I read the problem. Crazy concept. What? 0.025 came from right here. 2.5%. That's my rate. The decimal. We moved the decimal 2 places to the left. And it's 24 hours a day. So we typed in our calculator. 1 minus 0.025. Don't lose that decimal. I mean that 0. It's right there. 1 minus 0.025 should not be an error. Then raise that to the power 24.
I got 136.
I got 0.544615558.
Right, now take that times 2,500. Now, here's a tricky one. The calculator says 0.6. Does that mean we round up to 1,362 people?
Absolutely.
No, because we don't have 0.6 of a person. Normally, 0.6 tells us to round up, but in real life, we don't have that extra person all the way well yet. So we just write 1,361 people. And again, decay is going to look something like that. Okay, 2 more examples. Yesterday I opened a savings account. I deposited $100. If this account earns interest every day, an annual rate of 5.5%, how long will it take me to go to $110? So my future value is 110. 100 is my initial amount. 1 plus, yes, 0.055. T. We don't know it.
Oh, okay.
Okay? So what we're going to do is we're going to just put some numbers in and see what we get. So everybody put 1 in there. No, just put 1 in. You see what you get. So 1.055 times 100.
I got 105.5.
Right. So that gives 105
I want to get a cat.
and 50 cents.
I got 6.5.
Okay, try it again. 1.055 times 100. You should have got $105.50.
Oh, my bad. No,
Let's try 2 years. Someone said that. Let's try 2 years. So put in 1.055 raised to the power of 2 times 100.
I got
111.30, right? Okay. So in other words, it's going to be somewhere between 1 and 2 years, right? Okay. So let's try a year and a half. Well, you typed in 1.055 caret 1.5
Oh,
times 100.
I got 108. 108.
Yep. 108.36. Okay. So obviously 1.5 years is not enough. Trying to. So let's try 1.75.
No,
just try 2.
We already did 2.
Are you dumb?
Okay. So 1.055 raised to the power of 1.75 times 100. $109.82. That's pretty darn close, right? So, what is 3/4 of a year? How many months is that? What's 3/4 of 12?
It's 12 months.
Yes, there's 12 months. What's 3/4 of a year? Why do you keep saying 1? 1 and 3/4 means almost to 2 years. What's 3/4 of 12? Stop just shouting numbers. You have a calculator. This.
9.
Yes.
Woo!
3 times 12 is 36.
Baby mama though.
Divided by 4 is 9. So that means 1 year, 9 months.
I got it, bro.
So about 1 year, 9 months to get to $110. Maybe 10 months. Okay. Last example.
Wait,
What?
you scared the lot.
Okay. So right now we got about 1,300 students. So start with 1,300 students. When will it be down to 1,250? So 1,300 is the future. I'm sorry. Okay.
No one goes to something, so it's
So 1,250 is my end amount. 1,300 is my starting amount, which means yes, I have a decay problem. Now 1.5% is 0.015. So again, we're going to pick some numbers. Let's try 1. So let's do 1 minus 0.015. To make life easier, you can always just write this right now, so you don't have to do it every time. 0.985.
I got
1.
6.
You're not squaring, you're changing the 1, which is just that number. So 0.985 times 1300.
I got 106. I mean 1062.
1280.5.
Oh, yes.
Okay? So 1 year doesn't quite get it. Okay? Let's try 2 years. So do 0.985 squared times 1300. So 0.985 to the second power, then times 1300.
126.
1261.
1261.
Okay, so we're getting in the right direction, right? Let's try 3. We're trying to get to 1250. So do 0.985 raised to the third power times 1300.
I got 900.
1242. So we went too far, right?
So let's talk to
So it's not quite 3 years. Let's try 2.5. Bet. So 0.985 to the power of 2.5 times 1300.
I got
1251. Pretty darn close, right? So let's say about 2.5 years. Okay? About 2.5 years, we'll leave it at that. That's good enough. Okay? So we just guess and check. We pick some numbers, and we try to get as close as possible.